How Cloudflare was able to support 55 million requests per second with only 15 Postgres clusters. This is about CDN here. A team of entrepreneurs create a content delivery network to make the internet faster. Call it Cloudflare. We're talking about Cloudflare here. And so now Cloudflare serves around 20% of internet traffic, and the article is saying that they did it with only 15 PostgreSQL clusters. And what is a cluster? Cluster is a group of database servers, and they use Postgres to store metadata of services and handle the online transaction processing OLTP workload. Okay, so and again, what is a tenant? They are supporting the tenant, having different load conditions within a cluster, and a tenant is an isolated data space for a specific user or group. So far so good. So we will come to so what is saying that there are clusters of PostgreSQL servers, and then we have also introduced tenant into picture now, and we'll see how they all come together later on. So now we started talking about PostgreSQL scalability. Here's how they use Postgres SQL at extreme scalability. Resource usage. Main point that they're talking about is coming in through this picture. That see, as we talked about, there are many tenants, right? So tenant 1, tenant 2, tenant 3, and they want to query the databases. But see, through this picture, that tenant 1 is querying more often. Okay, tenant 2 queried once, tenant 3 queried once, but tenant 1 queried double of what they did. So what they're saying is Postgres connections are expensive because each connection is a separate process at the operating system level, and each tenant has unique workload, right? So this is tenant 1's workload is different from tenant 2's workload. And besides that, throttling misbehaving tenants. For example, let's say tenant 1 is misbehaving because it is sending a lot of queries, much more than the other ones. So besides that, throttling misbehaving tenants manually is a huge effort, and a single tenant might issue an expensive query. Thus, they might starve the neighboring tenant. So if tenant 1 is occupying all of the most of the connections, let's say, so it will starve the other tenants, right? So due to these, also a query is difficult to isolate once it reaches the database server. So once it reaches the database server, it is difficult to isolate. Hence, before reaching the database server, we can do something, and which is PG bouncer that they did here. So they use PG bouncer as a connection pooler in front of Postgres. So Postgres database servers are there. So in front of that, they made a PG bouncer. PG bouncer acts as a TCP proxy that holds a pool of connection to Postgres. Now, a tenant will connect to PG bouncer first, not directly to the database. A tenant connects to the PG bouncer instead of Postgres directly. Thus, it limits the number of Postgres connections to prevent connection starvation. And this PG bouncer is not all the time opening and closing connection. That's what it's saying here. It is maintaining persistent connections that the incoming queries can use. And the tenants are not directly dealing with the database, they are dealing with PG bouncer. So this so there are more advantages. Let's talk about them next. So but before that, yeah, so besides that, they use PG bouncer to throttle tenants using expensive queries. So now once you have another what do we call it, another infra, let's say, so another layer, let's say layer before your database servers, you can use this to throttle the expensive queries or misbehaving tenants or all of those cases. Okay, next, thundering herd problem. Thundering herd problem is what again, when Many clients query a server concurrently. It degrades the database performance. Thundering hard means basically means um, many clients are querying at a time. So PG Bouncer here avoids the thundering hard problem. And how? Because PG Bouncer is used to throttle the number of Postgres connections. So since we have PG Bouncer in front of the database servers, we can always maintain and keep a balance or control the number of Postgres connections. Um, okay, and it also explains here with a small example where thundering herd problem might occur. So it's saying the state of an application gets initialized when redeployed. It results in the application creating many connections to the database at once. In this case, thundering herd problem can occur as tenants compete with each other for Postgres connections. And that PG bouncer we talked about can be used to throttle the number of Postgres connections here. Now, about performance. For increased or for high performance, they don't use Postgres in the cloud, instead on bare metal servers without virtualization. This could be in itself another topic, but let's move on for now because this is very short. Now, even between PG bouncer that we talked about and the database, there is a HA proxy. What is HA proxy doing? This is for load balancing traffic between database instances. So they use HA proxy as an L4 load balancer. Do you know what an L4 load balancer is? L4 load balancer is layer 4 load balancer. Do you know what layer 4 load balancer is? Layer 4 load balancer. Layer 4 load balancer operates at the transport layer of the network model. So there are 7 layers, right? So at layer 4 load balancer operates, focusing on basic network information like IP address, ports, protocol to distribute traffic. And if I can show you all the layers, this is here. See, physical layer, data link layer, network layer, transport layer, session layer, representation layer, application layer. Which one is the fourth? Transport layer. That's the fourth one in which TCP and UDP comes. So what is it saying? They use HA proxy as an L4 load balancer, layer 4 load balancer. So again, what will the L4 load balancer have access to? See, IP address, port, protocol to distribute traffic. And HA proxy load balances traffic across primary and secondary database read replicas. Now next, coming to concurrency. The performance degrades if there are many tenants issuing concurrent queries. So they use TCP Vegas congestion avoidance algorithm to throttle tenants. And how do they do that? So they are using something as tenants transaction round trip time. So let's say transaction is issuing a query. So they can use the round trip time that it can take. Based on that, we can change the number of connections. So sometimes, if let's say that's how I understood it, that let's say the transaction round trip time is less, in that case more connections can be allowed, which are these peaks, and there can be less connections when there are more transaction round trip time. So let's go next. So it then increases the connection pool size as long as RTT does not degrade round trip time. Thus it throttles traffic before resource starvation happens. So and let's say you reach a point where resource starvation can start to happen, then you throttle the traffic. And do you know what throttling means? Throttling means, so ordering queries next. They rank queries at the PG bouncer layer using queues. So you are getting so there are queries coming from the user, and that from the user or tenants, and that reaches the PG bouncer before it goes to the database. So they are ranking the queries. So ranking the queries so that they can decide which one to allow and which one to not. So let's say when there is high traffic, peak traffic scenario, then the query which will take a lot of resources, they are deprioritized. So that's what they're saying here. So queries that need more resources get moved to the end of queue. Also, they enable priority queuing only in peak traffic to prevent resource starvation. In other words, a query does not wait forever at the end of queue in normal traffic. That's it. Next, we come to high availability. How do we maintain high availability? The general idea is they buy replicas. So they are using something called stolen cluster manager for high availability of Postgres. Stolen replicates data across Postgres instances. Besides, stolen elects Postgres leaders and does failover in peak traffic. And how are they? What is the architecture? Yeah. So they replicate a database cluster across two regions for high availability, and now in each cluster consists of three database servers. Okay, within a single region. So each cluster consists of three database servers, and this is replicated across two regions. The writes get routed to the primary region, and data get asynchronously replicated to the secondary region. Okay. Also, they keep doing connectivity tests between components to find network partitions, and they set up extra network switches and routers to avoid network partitions. Again, they are using something called PG Rewind tool for synchronizing Postgres clusters, and it replaces missing writes to the primary server that came back online after a failover. So let's say a failover occurred. That means a server got down. In that case, the PG Rewind tool is used for replaying the missing writes, so that the missing writes are updated in the server that failed. Almost that's it. And last few lines says they run more than 100 database servers including replicas. They offer services like DNS resolver, firewall, DDoS protection, and they use a combination of OS resource management, queuing theory, congestion algorithms, and even statistics for scalability. That's it. I think this makes sense. I hope this makes sense. So we talked about how Cloudflare works on this big scale, 55 million HTTP requests per second, and we talked about PG bouncer between tenant and database servers. We talked about how PG bouncer helps tackle the thundering herd problem. We saw how bare metal servers are used instead of cloud Postgres in the cloud for performance. We saw how HA proxy is used as L4 load balancer. We saw in how concurrency is handled. So changing number of connection pool, changing size of connection pool based on round trip time of a transaction, and then ordering queries at the PG bouncer layer based on resource usage, and then to maintain high availability, replication, and how the replication happens, and again for failover mechanism for to handle failovers, PG Rewind tool for synchronizing. So hope that made sense. See you. Bye bye.